The location of the expanders in the building plays a crucial role in the reliability of the K-mesh network. This video will guide you through the process of calculating the right number of expanders and identifying the proper places to install them. Expanders receive signals from devices and transmit them to the translator module, which is connected to the control panel. The system operates similarly to a cellular network. Much like mobile phones can automatically connect to a cell tower, wireless sensors link to the expander with the strongest signal and relink to a different one if the connection is lost. The signals will then travel through multiple expanders before reaching the translator. And this communication path is also established and adjusted automatically. The product name of the expander is WL8EXP. You can also reprogram the translator module to operate as an expander. The WL8EXP module needs to be connected to a 12 or 24 volt power supply unit, and the translator is powered by the control panel loop. Your job as a specifier is to put the sensors on the floor plans according to the National Fire Safety Code, and then provide them with network coverage using the expanders. There are three main approaches to designing the wireless network. On average, the system needs one expander for every 15 sensors. You can use this ratio to get a quick estimate of the number of expanders needed for the building. Installation Guide contains a table with typical values of communication range for buildings with different types of walls. This will help you determine the radius of the area covered by the expanders and distribute them evenly throughout the building. Communication Quality Calculator in the K-mesh Configurator software allows you to get a connection strength rating based on the distance and the number of walls between the expander and the device. Use this program to check the location of an expander and verify that it will be able to connect to all devices in its area. More thorough inspection can also be performed using the survey kit. Let's have a look at the process of designing the wireless network for a typical multi-storey building. The first step is identifying the location of the expanders on the floor plans. Start by putting two expanders on the opposite ends of the floor. Next, check the expected communication range using the table from the manual. In our case, the range is limited to 20 meters and 2 walls. Create 2 circles around the expanders with a radius that corresponds to the communication distance. In the center of the floor, there's a small area left without network coverage. Put another expander there and create a circle to indicate its range. The next step is verifying the locations of the expanders. Pick one of the expanders and find the device which is the farthest from it. In the Communication Quality Calculator, input the distance and the type of walls between the 2 points. The connection strength is displayed on a scale from 2 to 5. In our case, it is rated at 4, which means that the connection is stable. Given that the wireless link to the farthest device is strong, other devices in the expander's range will also have a reliable connection to the network. The same procedure should be performed for all expander locations. It's also important to note that the antenna pattern of an expander is spherical, which means that it can connect to devices one floor below or above it. Since there is a lot of overlap in communication areas of the expanders, most devices in the building have multiple backup connections to the network. To illustrate this point, let's look at a wireless system installed in a 9-storey building. The system contains 300 sensors and 3 expanders per floor. All devices are divided into 3 networks controlled by separate translators. This amount of network nodes is sufficient to provide each device with multiple communication paths. The chart on the screen distributes the wireless devices into several groups based on the number of connections available to them. As you can see, 95% of all devices can connect to 3 or more expanders. To get the same level of network reliability in your project, just follow our simple recommendations, and the K-mesh system will do the rest.